let's see. So we're going to learn about elementary functions and then piecewise functions. Piecewise functions you'll see a lot in calculus, and so sometimes students have a little bit of trouble putting those together, so I want to show you how to do that today then. Okay, so what we're going to start with is we're going to start with what we call elementary functions. Those are just the simple things like y equals x squared, y equals absolute value x. Those are the basic ones, okay? And background, you probably know a lot of these already, but we're just going to crunch these out real quick. So I'm going to have you make a table. You don't have this table on your handout. All you got to do for a table is just kind of go like that. You know, that's nothing to it. You don't have to put all those lines. So what I'm going to put here is x, and then I'm going to put, we have f of x equals x like that, okay? Now what you can do on this, x can be anything in this problem, so you can just, you know, pick some numbers. You'll see me over and over again just pick -2, -1, 0, 1, and 2. That usually is a pretty good, you know, thing to use, some negatives, 0, and some positives. Now this one, it just says that f of x is the same as x, so that's going to just come straight down like that. So that's your table of values. There isn't anything to calculate, okay? So what we're going to do is we're just going to plot these points and just kind of get what each of these things looks like. So now you want to go ahead and plot your points. So we go left 2, down 2, whoops, and so forth. And you'll get a straight line. This is an identity function like that, okay? All right, and then we got it. All right, so then we'll talk a little bit about domain and that kind of thing like that then, okay? All right, so there's nothing to that. What we're going to do is we're going to do this over and over again for all these elementary functions. And the domain on here, x can be anything, right? So remember, x can be anything. So we would just say -infinity to infinity. The range, the y can be anything. So there's no limit to that. So you just go -infinity to infinity. And then this is linear. Sometimes we call this an identity function. It's really just a linear function, okay? But it's identity function because x and y are identical. That's why we have that, okay? All right, so it shouldn't be anything to that, all right? Everybody with me okay? All right, okay. And then the rest of them, we got to kind of do some basic calculations on. So x squared, you probably know from your background, that's the parabola. So again, we're just going to do the same thing. We're going to have x, and then we'll have f of x equals x squared. Okay, I'm going to use exactly the same numbers. So I've got -2, -1, 0, 1, and 2. And then you can do all this calculation in your head. What you're doing is you're just squaring each x value. Okay, so if you take -2 squared, you get, of course, a positive. And then the rest of them you can just do in your head. If you do -1 squared, that's 1. 0 squared is 0, and so forth. Okay, you're going to be able to do most of these things in your head. Okay, so that's what we call a squaring function generally. That's quadratic, but we're just going to call that the elementary function is what we call a squaring function. Okay, all right. So tables of values is really like what your graphing calculator does. It just gets a bunch of points and plots them. So go ahead and plot your points. So we're going to go left 2 up 4, left 1 up 1, 0, 0, and so forth. Okay? So it goes like that. And that's what your squaring function looks like. Okay? What we do in the next section is we start doing transformations. So if you've had background for that with pre-calc in high school or something, you would have done that. So what's the domain? Can x be anything, or is there anything x can't be? So what's your domain? That's everything, okay? So you can square any number, okay? Now how about the range? Where are the y's going? From where to where? 0 to infinity, right? So your y values, lowest is 0, and then they get bigger. So you would say bracket 0, comma infinity like that, okay? All right, so you've probably seen the squaring function before. Everybody okay with what I'm doing? Okay, we're going to go through this fairly quickly, but you want to have the ability to just quickly put these together, because we're mostly going to focus on transformations. Okay, all right. So we got a linear, and then we have a squaring function. All right. Okay, we got several of these we want to go through. So on this next page, we'll do the cubic function. And again, we're just going to make a table. We're going to use those same values. In this particular problem, x can be anything. You can take any number and cube it or raise it to the third power. So just use the same things. That's kind of a good rule of thumb on most of these things, is just use those same numbers. Okay, and you can do this in your head. You don't have to write out the calculation you're doing. What do you get if you take -2 and multiply it out 3 times? You get -8, right? Okay, 3 negatives multiplied is negative, so that's -8 and so forth. And if you do -1 to the third, that's -1, okay, and so forth. And then the rest of these you can just do in your head. If you can do them in your head, which you should be able to, that's fine. 1 to the third's 1, 2 to the third's 8, okay, like that. Now we talked a little bit about, in the last period, what an odd function was. And remember, an odd function just means that if you have an opposite x, you also have an opposite y. So that's what a table of values would look like on an odd function, is like that, okay? So let's just plot the points, and we'll kind of talk about what we have. So let's see, we got -2, -8, -1, -1, 0, 0, 1, 1, 2, 8, like that. So that goes like that. All right, that's an odd function. So let me ask you this, since we learned this last time. How is that symmetric? About what? About the origin, right. So this one it's got the origin symmetry. It's an odd function, okay? Domain, what's the domain? What can x be? Anything, okay. How about the range? Anything, okay. You're always going to get a number. If you cube a number, you're going to get a number, okay. So you can tell by the graph the y's extend through all real numbers, okay. And then your type of function on this is just going to be what we call a cubing function, okay, like that. And that's another one of the basic ones you have there, okay? Okay, so it's kind of good to memorize how these things go, but you can always figure it out by making a table of values, and there's nothing to it really, okay? Okay, now the next one is a square root. So it's a little bit different on the table on this. So I can't just use anything for x, can I? I can't do the square root of -2. I mean, that's an imaginary number. So what kind of numbers do I need to use in my table for x? Positives, and you want to start with 0, okay, because you can do the square root of 0. Now, what I would do on this, you can go to 1, because the square root of 1's 1, but I wouldn't go to 2, or I wouldn't go to 3, because they're decimals. I would move on to 4, like that, because I know the square root of 4 is 2. Okay, and then I would move on to the square root of 9, because I know the square root of 9 is 3. Okay, so that's what I'd do just to make it simple when you do that. And then the rest of this you just do in your head. So square root of 0 is 0, square root of 1 is 1, and so forth. Square root of 4 is 2, square root of 9 is 3. Okay, so you just use positive numbers on that and 0 because of the domain. So what would the domain be then? In interval notation, how would that go? 0 to infinity. Would the 0 be a bracket or a parenthesis? It'd be a bracket because you are including that. So 0 is included. So we start at 0 and then we go forever like that. Okay? And let's see. Let me plot my points here real quick. Okay, so you just put your points and estimate. So that's how the square root function goes like that. Okay? And what's the range look like just now that you see your graph? Where does y begin and where does it end? Starts at 0, right? And it gets higher forever. Okay, so your range is this way. So that's also going to be 0 to infinity. And then this is just a square root function is what that is. So that's another elementary function. Okay, I think there's about 8 of these elementary functions we look at. Okay. All right, so you want to kind of get real familiar with how they look. So when you encounter the more advanced problem, you can know the shape of it, then we'll do the transformations, okay? All right, I'll slide this up just a tad bit here. And the next one, this one you got to kind of do a little bit differently. So I'll kind of show you the way that I'm going to think through this. So On this one, what I'm going to do is I'm going to choose these numbers just for a certain reason. So I'm going to choose like -10, -1, 0, 1, and 10. Okay, you just kind of got to get the idea of what's going on this problem, and then I'll show you something on the graphing calculator on this. So first of all, would this function be undefined anywhere?
Yeah.
Where?
0.
X equals 0, right? Okay, so basically, you can't have a 0 denominator, so you're going to have undefined there, okay? And we're going to study a little bit more about these a lot more in depth a little bit later in the class. So what we have is this is called a vertical asymptote. Okay, if you have pre-calc before, you've learned about asymptotes probably. So what you do on your graph is you put like a dashed line like that, and then we'll plot the points and I'll kind of talk about what it does, okay? And anytime you have that's called a rational function, you have an asymptote where it's undefined, okay? Well, if we did the calculation on this is what would happen. So if I plugged in -10, I'd have 1 over -10, which is really -0.1. So that's -0.1, right? If I plug in -1 into the bottom, then I have 1 over -1, so that's -1, okay, and so forth. If you plug in 1 into the function, you'd have 1 over 1, which again would be 1, and then plug in 10, you'd have 1 over 10, which is 0.1 like that, okay? So what we want to do on this is let's just kind of plot these points. So if you go out to -10, well, what's really happening is you're just barely above the x-axis. Okay, you're way out here, you're just 0.1 is just a tad bit above the x-axis, like that. Whoops, I'm doing that in the wrong place. That needs to go underneath because that's negative like that. So if you go do this graph, just kind of extend this out a couple of notches, and then just put it barely under the x-axis like that. You have the point -1, -1. It goes like that. And I'll kind of going to get out the graphing calculator in a minute and kind of show you what happens. What happens is the graph goes like this, and whenever you have a vertical asymptote, the graph usually either goes down to infinity or up to infinity. Actually, it always does that if you have a vertical asymptote, and then it just levels off at the x-axis like that, okay? And if you do the other points, you have 1, 1, and then again, if you go out to 10, we're just a tad bit above like that. So the shape of this graph kind of does something like this. And I'll explain this on the graphing calculator because you want to understand why the graph does this. Okay, and the math is pretty simple to show. Okay. All right, why don't you, if you got your calculator, get your calculator out, because I think it's kind of helpful on this problem to look at it on the graphing calculator, and so I can just show you a couple of things. So the idea is I'm just going to put in 1 over x, and we're just going to graph that in a standard window. And if we do that, I'll just go, again, I can go zoom 6 is kind of the quick way to do that, and you'll see kind of the same thing that I got there. If you have an older calculator, sometimes it'll kind of look like this. It'll look weird, kind of like that. Is that going like that for anybody? Okay, that's like a TI-83 or something. That's really showing an asymptote, so this is what the graph actually looks like, is like that. So what I want to show you is this, okay? The reason this graph goes to negative infinity here is if you type trace, and if you put a number in, like if you put in trace, just take a number that's barely to the left of 0, like say negative 0.01. Okay, if you're real close to that asymptote, see I got negative 100. So the idea is the closer you get to that asymptote, the further down the graph goes. So now I'm going to trace see something that's even closer, and see now it's negative 1,000. So the idea is, what happens is when you take 1 divided by a very small number, it gets bigger, right? So if you take 1 divided by something very, very small, it's just going to get bigger and bigger. So the closer you get there, the further down that goes. Does that make sense to you? Okay. So the idea is if you take like, it's kind of like this. If you do like 1 over 0.1 is 10. 1 over 0.01 is 100, 1 over 0.001 is 1,000, and so forth. So it just gets bigger when you get closer to that asymptote. Is that logical or sensible to you? Okay, so that's why it does what it does. And then the same thing here, the graph would just get larger. Yes? Can you just go back to what you entered into the window? What I did on what? What you entered into the window. On the calculator? Yeah. Yeah, okay. Yeah, that's fine. So what I did is I put in 1 over x, okay, because we're looking at this function, okay. I graphed in a standard window. A fast way to do that is just zoom 6. You'll see me do that all the time. That just puts it in a standard kind of window like that. Now what I was doing with the trace is I was going trace, and see I was picking a number that's real close to 0. So like if you did, what I did a minute ago is I did trace negative 0.01. And that gave me a number that's very small. So what I'm trying to show you is the closer you get to the y-axis, the further the graph goes down. Okay? And if you go on the other side, the same thing happens. Okay? Does that make sense? Okay? You want to understand this. Okay? So we're going to do rational functions a little bit more in depth here. I want to show you one other thing. If you were to go second graph to open up your table of values, so you can always look at a table of values, second table, what you'll find on this is the further you go down, if you just kind of scroll through your table, what's happening to the y values on this is x gets bigger, what's happening to y? It's getting smaller and it's going to 0, right? It'll never hit 0, but the idea is if you go to infinity, as your graph goes this way, the graph just levels off of the x-axis. That's called a horizontal asymptote. So that's how that goes. Okay, one way to understand that is just kind of plug in some numbers on the calculator. Okay, so how about the domain? Is there anything x cannot be? Can't be 0. You can't have a 0 denominator, right? So if you do a interval, you would have to write this like this. You'd have to say negative infinity to 0 with a parenthesis, and then union 0 to infinity like that. By putting those parentheses there, that's how you're excluding. You're just saying it's everything but 0, okay? How about the range by looking at my calculator? Is there anything that y never hits?
Negative 1 to 1.
Not quite. Range is this way, so it's going to go to infinity that way, right? And then it's going to go to negative infinity that way. But there's one thing it can't be. It can't be 0. Okay, because this graph is never going to touch the x-axis. It's just going to get closer and closer and closer to it. That's the idea. So your range would actually be the same thing. You would just say, in interval notation, you just say negative infinity to infinity, union 0 infinity. Okay? All right? That's the one that's you know, that you have to think about a little bit more. The other ones are pretty straightforward and simple. And then this one is, we usually call this like either a reciprocal function. It's really a rational function is what it is. So we're going to study, again, rational functions a little bit more in depth. Okay? All right, so far, are we okay? I'm just making tables of values and plotting points. That's kind of the idea. And if you ever need to create these, that's what you're always going to do, is just to get them accurate, is do tables of values and so forth. Okay? All right. Okay, let's go to the next one. Okay, those of you who have an outstanding background, what do you remember about absolute value of x? What does that look like? Yeah, that's the kind of the V shape. Okay, so what we'll do with this one is you can do the absolute value of any number. You just want to remember that if you do absolute value of a negative, it just turns into a positive. Or if you do the absolute value of 0, that's 0. And if you do the absolute value of a positive, it's a positive. Okay, so what we're going to do with this one is on the table, let's just use -2, -1, 0, 1, and 2 like that, and then we're just going to crunch these out. Now you can do every bit of this in your head. So if you do absolute value of -2, that's 2. Absolute value of -1 is 1, and so forth. Okay, absolute value of 0 is 0. Absolute value of 1 is 1, like that. Okay, that's the idea. So you don't remember what absolute value is. You're just really absolute value of negative is positive, and absolute value of positive remains positive. Okay, so if you plot these points, we'd have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So that's that kind of V shape. Okay, so you just kind of sketch this in, and it's going to go like that, and that's the idea. Okay, so you want to know what the absolute value looks like. Okay, what is the domain on this? Is there anything x cannot be on an absolute value? No, you can do an absolute value of anything, right? You can take an absolute value of any number you can think of, so that's going to be all real numbers. Okay, all right, range, what does it look like the range is? Where to where? 0 to infinity, right? Okay, so that's your lowest y, and then the y's get bigger from there. So what you would have is 0 bracket, comma infinity like that, okay? And then your type of function is just an absolute value like that. Okay, any questions about absolute value? Okay, all right. So we got the next one, there's just 2 more I want to look at, and then we'll kind of get in the piecewise functions, okay? Do you guys remember from your background what a cube root looks like? How are you doing that? Kind of draw out what you were doing? Okay, kind of like this. You're going to see this thing kind of go something like that. Okay, the x to the third that we did a while ago kind of looked like this. So when you do it backwards, it kind of goes like this. Okay, so that's the idea. So what I want to ask you on this, first of all, is this. Is it okay to do a cube root of a negative number? So that's what you have to understand. Is that okay? Yeah? Because the answer to the cube root of negative 8 would be negative 2, because negative 2 times negative 2 times negative 2 is negative 8. So don't confuse that with a square root, where you can only do square roots of 0 and positive. So actually in this one, you can do the cube root of any number. Now what I would do is I would pick things I know, like negative 8. I wouldn't use negative 2. I'd use negative 1, because that turns out to be a whole number, and then 0, and then 1 and 8 like that. Okay, those are what we call perfect cubes. Okay, so if you do the cube root of negative 8, that's negative 2. If you do the cube root of negative 1, that's negative 1, and then so forth. Okay, cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Okay, so we got that. Just in case you need to know this, because I know a lot of you haven't used a calculator in a long time, but on a TI, let me show you where that is. So like if you press your math button, okay, you got your math button, you should see the third root down here. So if you ever need to do a third root of a number, you just go math, option 4, and then you can type in whatever you want to type in, and then that'll work that out for you, okay? Because you'll encounter that from time to time, okay? But I wanted to use just easy enough problems that I can, or easy enough numbers that I could do those in my head. Now, if you plot these, this would be negative 8, negative 2, negative 1, 0, 0, 1, 1, 8, and 2 like that. Okay, so it goes like that. All right, okay. Now let me ask you this question, okay? Just kind of see if you're making some connections here. What do we call a function if opposite x had opposite y? What did we call that in the last class?
Negative.
What?
Negative?
No. Opposite x, opposite y, that's what kind of function? Even or odd? That's odd, okay? That's an odd function. How is this thing symmetrical? About what? About the origin, okay? So origin symmetry means you can fold over y, then fold over x, and they come together. So this is another example of an odd function. Okay, so that's an odd function. All right. So the domain would be all real numbers. Okay, you can take a cube root of any number, including negatives. The range is same thing. It's going to be positives and negatives, so it's everything. So you get that. And then the type of function is this is just a cube root function like that. Okay. All right. Okay. Yes.
So
Yes. If x is opposite, then so is y. See, that's negative 8, 8, negative 2, 2. Negative 1, 1, negative 1, 1. If the x's are opposite, the y's will be opposite. Okay, that's what a not function means. Okay? Now, if you look at the one up above, the one up above is an even function. Because what happens? Opposite x, what do you get? Same y. You see what I mean? Okay? So as you're doing these problems, you can kind of tell mathematically why they might be odd or even. Okay, so that's the idea. That's what we talked about last time. Okay? Okay, one more to do, and then that's all your elementary functions. So this one, I'm just kind of giving an example. What you're looking at is like if you had f of x equals some number a. A is just some arbitrary number. The way this one goes is like this. If you made a table of values, this is how the table of values would go. On this one, it just says f of x is always negative 2. That's what that says. And then x can be anything. Okay, just to kind of show you why the graph does what it does. So if I just picked a couple of numbers, the point is y is always negative 2. So what would the graph look like if the y value was always negative 2? How would that go? Yeah, like that. It would be a horizontal line. So the way this graph would go would be through negative 2 and then horizontal like that. Okay, that's a constant function. So constant functions are going to give a horizontal line like that. Okay. All right. Now the domain on this on a constant function is always all real numbers. All right. Always is, because x can be anything. But what's the range? What do you think the range is? Negative 2. Exactly. That's all it can be. You don't really write that in an interval. You just say y equals negative 2. That's your range. It's only negative 2. So that's how that goes then. Okay? All right. So that's kind of what I'm going to do there. It takes a little time to go over those things. Now, the part of this section that students sometimes have to work on a little bit is the piecewise functions. The elementary functions, you just need to know how to put those together, and the more you can memorize those, the better off it's going to be for you. You want to know if it's square root, that it does this. If it's absolute value, it's the v. You want to get that in your mind if you don't have that in there already. So the other thing we talk about in this section is a piecewise function. And if you go on to calculus, you'd work with these in calculus all the time. And the idea is you have two pieces of the function. Okay? So what this is like this would be y equals 2x minus 3, but you would only use x values less than negative 2. So it would be a piece of that linear function. And then this second one, y equals 5 is a horizontal line, but you're only graphing that when x is larger than or equal to negative 2. So piecewise functions, you generally have two or more parts that are defined on different intervals. That's what we mean by a piecewise function, okay? All right, so we're going to do several graphs on these and a few other things, okay? So let me kind of show you how you evaluate things then, okay? So if you look at example 10, we're not going to graph it or anything. We just have two pieces. We have the first piece defined when x is less than 1. Then we have the second piece defined when x is greater than or equal to 1. So if you're going to do f of 1, that just means plug in 1, plug in x equals 1, okay? Function notation, you're trying to find y. So if x is 1, which piece does it go into? The top or the bottom?
The bottom.
The bottom. How come? Because it says x is greater than or equal to 1. So if x is equal to 1, you're going to plug that into the bottom piece then. Okay, so it's because of this. So what you would do is you would, since x is 1 and fits here, you would just do negative 4 times 1 plus 4. Okay? If you work that out, you'd have negative 4 plus 4 would be 0. Okay? That's why I plugged into what I plugged into. Okay? All right? If you look at the next one, you have x equals 0. So where would this plug into? If x is 0, does it belong in the top function or the bottom one? The top, okay? How come the top? Okay, because 0 is less than 1, okay? So what you'll do on this is you will do -3 times 0 minus 2, okay? That's going to give 0 minus 2, so that's going to evaluate to give an answer of -2 like that, all right? Does everybody understand how I decide which piece to plug into? Okay, all right? And then how about the 10? If you have x equals 10, is that going to go in the top or bottom?
The bottom.
Goes in the bottom because 10 is greater than or equal to 1. So you plug that into the bottom. So you'd work out -4 times 10 plus 4. So that's -40 plus 4. So that's -36. Okay, that's the idea. So you have that inequality to tell you which numbers go where. All right, that's the idea. Is there any question about that? Yeah.
Is there going to be a situation where you can actually plug to both
No,
inequalities?
because it wouldn't be a function. If you ended up having, like for instance, if I had, instead of x less than 1, if I had x less than or equal to 1, then you would end up, it would fail the vertical line test. You would actually have a function value on both, and you would go through 2 points. So these are functions. So when we do graphs, it will pass the vertical line test. So it's either going to go in one or the other. Otherwise, it wouldn't be a function. Does that make any sense? Okay, so that's kind of the idea. Okay, now let me show you how to graph piecewise functions. And the best way that I've learned to kind of help people do this is what I recommend you do, is just do a table of values. Then it ends up being a matter of doing arithmetic and plotting points. Okay, so watch carefully how I do this. The first thing that we're going to do is we're going to do, on this table, you want to make 2 tables. So the first table, we're going to have x, and then we're going to have, I'm just going to put in f of x equals -x plus 2. So we're just going to focus on the top piece only. Okay, now what we've been doing today is just kind of picking x's, all right? Now, what kind of x do you need to use here?
Anything less than 0.
Anything less than 0, right? Now, you need to use 0, okay? And there's a reason, because you got to know where this thing comes to an end. So in my table, I'm going to do numbers that are less than 0, but I'm also going to do 0, okay? So that's what you want to do. You want to put a 0 here, and then you want to put a little note to yourself that when we do the graph, that endpoint is going to be an open bubble. It's an open bubble because that says less than. If it said less than or equal to, it would be a solid bubble like that. Okay? That's the idea. Now, let's just pick a couple of numbers that are less than 0. And keep it simple. Let's do like -1 and -2, and that's good enough. Okay, so this is a line anyway. Now, you want to plug into that top function, and you can do this in your head. I don't care if you do it in your head. You're going to do -0 plus 2, then you would do -1 plus 2, then -2 plus 2. Okay, like that. You're doing -x and then adding 2 to it. Okay? So if you work this out, the first one would be 0 plus 2, so that's 2. The second one would be what? 3, good. So that's 1 plus 2 is 3. And then the last one would be what? 4. Okay, like that. Okay? So what you want to do is you want to go ahead and plot these 3 points. And when you do 0, 2, make sure that you show that with an open bubble. Okay, and that's because the 0 is not included, but you have to show where that interval comes to an end. And then the rest of them you can plot -1, 3, -2, 4, and so forth. And see, that's a line, and it's going to go to the left, because if x is equal to 0, of course, we're going to the left like that. So that's a piece like this. Now, I'll tell you what I see students do all the time on this. Students want to just continue to go this way. Why does the graph not continue to go that way? Because it says it only works if x is less than 0, okay? Your graph stops there and goes that way. It doesn't continue that way. Okay, you got to pay attention to those intervals when you do that then, okay? All right, now the next piece is this. We're going to do exactly the same thing. We're going to make another table of values. This time it's going to be f of x equals square root of x plus 3, like that, okay? Now, look at your inequality. X is greater than or equal to 0. What kind of numbers do I need to choose for X? I need to start with 0, right? And the 0 will be solid because of the equal to sign, and then just anything bigger. Now, I would use numbers I know square roots of, so I don't have to do decimals. So what I'm going to do here is use 0, and then make an indicator to myself that that is solid. Okay, that's a definite point on that. And then I'm going to do numbers I know square roots of. I know the square root of 1. I know the square root of 4. I know the square root of 9. That's good enough, okay? All you need is 2 or 3 points just to get the idea. Now you plug it in, and you can do all this in your head. So you're going to do square root of 0 plus 3. So that's going to be 3. Then you do square root of 1 plus 3. So that's 1 plus 3. So that's 4. Square root of 4 plus 3 would be 2 plus 3. So that's 5. And then finally, square root of 9 plus 3 is going to be 3 plus 3. So that's 6. Okay? Does everybody understand why I chose what I did for X? Okay? That inequality tells you that, see? Now you can go plot these points. So if you have 0, 3, that means you're going to put a solid dot on 0, 3. Then you'll have 1, 4. You'll have 4, 5, and so forth. I'm only going to plot those 3 points, and that's kind of, the square root function always does that kind of swoosh, kind of like that. All right? And that's what your graph looks like. Okay? All right? You guys understand what I did? You understand my table of values and why I chose X. That's the whole key. All right? Because mostly it's arithmetic and plotting points. Now let me ask this question. Does this pass the vertical line test? Yeah, vertical lines are always going to go through one point. Even here, it's only going through that solid. So one thing that I tell students to do, when you graph a piecewise function, it's supposed to be a function. So like if you weren't paying attention and made that line go on forever, it wouldn't be a function anymore. So you're going to have a piece and a piece, and the whole entire thing should pass the vertical line test. That's the idea. All right, any questions on what I did? Okay, all right. All right, so I'm just going to do one more, and that'll kind of close off what we do here, and then we'll start on the longer section. This section is actually pretty short. Your homework on it is pretty short, but the piecewise function is the thing you want to probably work the most on. This one, we're going to have to do 3 tables of values. Okay, so what we're going to do on this is we have x, and then we have f of x equals 1. Okay, now let me ask this question. What if you graph y equals 1, what does that look like? Y equals 1. That's a constant function, so what does that do? Goes like that, right? Okay. So the other thing I want to ask you is, what kind of numbers do I need to use on this table of values? What is that telling you? That's telling you between -3 and 4, right? Is that -3 going to be solid or open? That's solid. It's got the equal to on it. So what I'm going to do is I'm going to start like with -3, make a note to myself that that is solid. Now you don't have to use all these numbers. You can, do another one if you want to, but I'm going to go to 4, and then the 4 is going to be which one? Open or closed? Solid or open? Open. That's open. Okay. So we got that, like that. And then these things are always 1. That's why we call it a constant function, because f of x is constant. It never changes. Now, if you plot those 3 points, that would be exactly like what that piece needs to look like. So I'm going to do this like in red here. So we got -3, 1, and that one's solid. Then we got, let's see, 0, 1. And then I got way over 4, 1, but 4, 1 is open like that. And then that's a horizontal line like that. So that's piece number 1. That's what you do. Okay? All right? Okay, and let's see. We need to go to a second table. And what we're going to do on this is we have x, and we have f of x. Now it's absolute value of x. Remember, the absolute value of x is the one that looked like a v. We're only going to do part of that, though. And again, same concept. The numbers you're going to use are between 4 and 9. The 4 is solid, the 9's open. Okay, so on our table of values, we want to go like a 4, and just make a note that that's solid. And then we're going to go all the way down to a 9, and that 9 is going to be open. Okay? Well, what's going to happen on this then is if you do the absolute value of 4, of course you get 4. Okay? Now you can put all these points if you want to. If you did 5, that would be 5, 6 would be 6, and so forth, and then 9 would be 9. Okay? So you're just doing the absolute value of that number. So we want to go ahead and just plot those points. You're going to have like a line. So if you plot 4, 4, that's going to be over 4, up 4. That's solid. And then if you go to 9, I guess we need to make our graph go out a little bit here. So that would end up being at 9. You'd be all the way up to 9 like that, but that would be open. Okay, kind of like that. So I'm just kind of estimating that. And that would be the second piece like that. Okay? All right? You with me there? Okay? All right. Now what's going to happen on the other one is this. You're just going to do a square root, and you're only going to do that from 9 to 10. So we do square root of x, and then we're only going to worry about 9 and 10, okay? 9 is closed, 10 is closed. Okay, so you would have at 9 and 10, you'd have closed there. So you're just going to do these 2 points. So square root of 9 would be 3. Square root of 10, I don't know, it's 3 point something. You can do that on your calculator if you want to. It's a tad bit bigger than that. So then if you go through and plot these points, you'd have the point 93, and that one would be solid. And then the other one beyond that would just be a tad bit higher. So it would look like a line like that. So I'm just plotting the point 9, 3, and 10, 3 point something. Okay? Now, if you look at my graph, does that pass the vertical line test? Okay, everybody know what I mean by that. It is a function. Every vertical line, no matter how you draw it, will go through 1 point. Even there, it's going through 1 point. Okay, you're never going to have a situation on a piecewise function where you have solid, solid. Because if you do, that's not a function anymore. Does that make sense? Okay, so that to me is probably the best way to learn how to do piecewise, is just do a table of values for each piece. Okay, that's probably the safest way to learn how to do that. You can, if you want to research this, like if you went to something like YouTube, and if you entered something like graph piecewise, if I had time, I'd show this, and if you wanted to come by my office, I could show you. You could put in a search graph piecewise function on TI-83, 84, and they'll show you how to do that. Okay, to me, for our purposes, it's just as well to just do it by hand. Okay, don't rely on your calculator. Okay, all right, so how do you feel about piecewise functions? Well, I see students don't do well on this. From years of experience, I see all kinds of problems. But if you follow this and just make the table of values, crunch it out, it becomes an exercise of arithmetic and plotting points. And you know the difference between solid and open. All right, any questions about any of that? Okay, all right. So let me close this off.